let's first understand why this page replacement has been occurred. So let's assume that this is the logical memory, or you can say it is a virtual address space for a particular process, and that process is divided into, let's say, 8 number of pages. So how many pages are there? So number of pages are 8. Okay. Now, in the page table, we'll make the entry of the pages. So we have the number of pages 8. So we have in the page table entry 8 entries. But in the main memory, we are getting only 3 frames available. So you can see the page number 0 is in frame number 4. And this is the valid invalid bit. It is saying valid and invalid. It means valid is mean 1 and invalid is 0. So whenever we have 1, it means that that particular page is available in the physical memory. If it is 0, the page is not available in the physical memory. So when CPU will generate the logical address, which is divided into page number and the offset, it will look for the page number here. And let's say if it is looking for page number 3 and it is not there, means this is invalid, means the valid bit says 0. It means that this page is not there into the physical memory. So what will happen? Here comes the concept of page fault. So what is page fault? A page fault occurs when a CPU attempt to access a block of memory which is not stored in the physical memory or the main memory. Then this particular page fault occurs. And when page fault occurs, then what will happen? The fault notify the operating system that it must locate the data in virtual memory, then transfer it from the storage device such as hard disk drive or secondary storage device to the RAM system. So what will happen? We'll look for the disk. Here we have the virtual memory, or you can say here we have virtual memory or the copy of all the pages which is here. And then let's say we require the page number 3, and page number 3 is nothing but the D, and we require the D, and D will be given to here. Let's assume that. So here it will be what is that? It will be 7. So in frame number 7, I got D, and now this bit will be updated to 1. So it will become valid. So the whole process, what happened into the whole process? In this, whenever there is a page fault occur, the virtual memory manager will be activated, and the process which is running will be blocked. So the first thing will happen is the virtual memory manager will be activated, then the will block the running process, then the virtual memory manager will contact with the disk manager, which is a file system of the operating system. The disk manager will concern with the device driver, because we are looking for the device which is a hard disk drive, right? Hard disk drive where we have the virtual memory available of that particular process. And this device driver will contact the device controller, which is a hardware for accessing this particular disk. And then the disk controller will get that particular page into the physical memory or into the main memory, and the page table will be updated. The whole process is taking time. That particular time is called page fault service time. Page fault service time. Okay. And at that particular time, nothing will be done. There is a, you can see this is a type of interrupt that will be occur into the system. So the concept here, how it is working in the page fault. So whenever there is a page, whenever there is a demand of the page and this page is not available, then there is a trap. Trap means there is a page fault. So the operating system will be giving this problem to the virtual memory manager. This virtual memory manager will contact the disk manager. Disk manager will contact the device driver. Device driver will have the control into the device controller, and it will give the command to the device controller. Device controller will get into the disk and bring the missing page into the physical memory and put into the free frame, and then the page table will be updated, and this invalid will be updated into valid, and then the reset instruction will be given to the CPU. This is the thing that will be done into the page fault. So whenever there is a page fault occur, the whole process will be done. So let's assume that we have the whole system available, and let's say there are 8 pages, the virtual address space, and in the page table, this is the page table how it look like. This is the page table how it look like. Assume this is a virtual address space for that particular process, and I am drawing the physical memory. So in the physical memory, A, C and F is there, right? A, C and F is there. In 0, 1, 2, let's assume that we have only 4 frame available into the main memory, main or physical memory. You just forgot this particular for some period of time. Now, if we are demanding the page, let's say page number 3. So for the page number 3, if we are demanding, and page number 3 is invalid, so it will contact, and this invalid page will be loaded into the D. So D will be coming into the space here. Let's say it is coming here in this, and okay, so we assume that it is coming here, D is coming here. So what is the space of the D right now? It is in third frame. So it is in the third frame. So right now this one is going into the third frame, and route is valid. Now again, you assume that it is, now the next time it is accessing the page number 6. It is accessing the page number 6. Now what is in the page number 6? Page number 6, it is G. And now page fault occur because of that. So it is accessing G. G is there in the virtual address space or the virtual memory. From the secondary memory, we have to put into the main memory. But here, all the slots are full or all the frames are full. So what will we have to do? We have to replace any of the page. Let's say if I am replacing A, and I am putting here again. So what are the things that we have to look for? So we know that there are many other optional information that is there. This is telling about the availability of the page, right? Page available or not is with the valid and invalid bit. Let's say there is a dirty bit. So what is a dirty bit? Dirty bit will tell about the modification has been done or not, right? So if there is a modification that has been done on A, so what will happen? So let's say the modification, if it is done, so modification means 1. If modification not there, then it is 0. If modification is done, so what happen is A will be taken into the secondary memory. So as I told you, when there is a modification in the main memory, that particular page will be taken into the secondary memory. That process is called swap in. And why we have to do swap in? Because this page is the old page and the modified page is here in the main memory. So we have to take it, and we'll know that with the help of dirty bit. and we have only this telling us that whether that page is updated in the main memory or not. Okay, so that also we have to take care. And this particular page that will be replaced is taken care by the page replacement algorithm. So we have many page replacement algorithm which will tell us that which page has to be replaced. And let's say if I am replacing page A and I'm putting page number, let's say G. So G I am putting here. Page number 6, G I am putting here. So G will be, if G is coming into that particular main memory, so definite into the particular main memory, so it is now in the position 0. So I have to put here position 0, and this will be valid. This is how it will be done. So whenever there is a page fault occur, there is a process that an operating system will handle as a trap or as a interrupt. And during that time, no process is executing into the CPU because process has been blocked, and the whole process will be taken place after the page will be replaces. So the whole process is used in the page fault.